Hey everybody. So today what we are going to do is we're going to get prepped for our next chapter. And our next chapter involves ratios, which is a really important piece of what we do in 6th grade math to get you set up for future math. So our goal today is we will define and write simple ratios. Okay, so we are all set. Give you just a second to get caught up and get our... Alright, so the most important thing that we start with is you have to have a very solid definition for a ratio. And how we define a ratio in 6th grade. A ratio is a comparison of the relationship between two or more quantities. Sometimes we can call that as numbers too. A comparison of the relationship between two or more quantities. Give you a second to get caught up. Now the good news for us also is that ratios work in a really similar way to fractions. They're different, but there are a lot of similarities. And since we have done so many things with fractions, the numbers, you're going to notice a lot of things that you already know how to do, which is fantastic. So when you are doing a ratio, a comparison of the relationship, let's say that I'm going to compare two numbers. So I'm going to compare 4 blue dogs. And yes, dogs could be blue. To 3 orange dogs. So a couple things before we write them are super important. The first thing is the wording of the ratio is critical. You can't get in a big hurry when you're trying to write your ratio. So the wording of the question is super important. So what I want to know is I want to know the ratio of orange dogs to blue dogs. So this is why the wording is so important. If you think about our ratio, on here I said 4 blue dogs to 3 orange dogs, but my question asks for the ratio of orange to blue dogs. So there are also, we're going to kind of work this in too. There are 3 ways, whoops, interesting spelling, 3 ways to write a ratio. So this is one way. So you can say my orange to blue is 3 and then a colon 4. That's one way. A lot of people write their ratios with the colon. 3 to 4. Some people will write it this way. 3 to 4. That also is a ratio. It looks like a fraction, but if I asked you the question ratio-wise, you would know that it's 3 to 4. And then the last one is we can actually use the word 2. 3 to 4. So what have you done with this ratio? You made a comparison of the relationship between the orange and the blue. And the orange and the blue is 3 to 4. And what that means, this is also kind of important, for every 3 orange, there are 4 blue dogs. So if we moved it up, if I wanted to keep the ratio the same, if for every 3 orange dogs there are 4 blue dogs, then if I had 6 orange dogs, there would have to be 8 blue dogs. If I had 9 orange dogs, there would have to be 12 blue dogs. So you want to keep that ratio the same each time. Think about it this way. If you like to cook and you have a recipe and it serves 4 people, but you're not having 4 people come over, you're going to have 40 people come over, but you want it to taste the exact same, then you have to keep the ratio of your ingredients the same. So if you make it for 4 people or 40 people, it should taste the exact same. Okay, let's do a little comparison. So let's say that we have marbles, and I have 8 blue, 4 green, and 6 red marbles. Give you just a little chance to write that down. Pause if you need to. Okay. Well, let's say that I want to know the ratio of blue to red. So my ratio of blue to red, I check the wording really carefully. Blue to red means 8 to 6. So my ratio is 8 blue to 6 red. I could also do it this way. I'm going to leave a little space because I'm coming back to this. 8 to 6. Or I could do 8 to 6. Now here's where the fraction part works in. You've done this before. We also want to be able to reduce ratios. So if I do 8 to 6, they're both divisible by 2. So that means that ratio simplifies to 4 to 3. Okay. I'm going to use some space here. Let's say that I want to do the ratio of red to green. Okay, so I'm really careful. I check my word. Ratio of red to green. Well, there are 6 red to 4 green. That's my ratio. But I also know 6 to 4, they're both even numbers. I can divide them both by 2. So the ratio would be 3 to 2. Okay, let's do a little practice. Simple, basic ratio. So let's say that you have 12 bananas. You have 8 apples, 5 oranges, and 3 pumpkins. We'll make it weird. All right, so all different ingredients. Now let's talk about a comparison of the relationship of them. So let's say that I want to do oranges to apples. Okay. So now I check my wording really carefully. My oranges to apples, oranges are 5 to my apples, which are 8. And can I simplify it? No. So the ratio stays 5 to 8. And what that means is for every 5 oranges, there are 8 apples. Okay, let's try another one from there. How about if I do pumpkins to bananas? Okay, give you a second to think about it. Okay, if I go pumpkins to bananas, that's 3 pumpkins compared to 12 bananas. But wait, it can simplify. So these are both divisible by 3, so that was reduced down to 1 to 4. So that's an equivalent ratio. You reduced it down. I could say this: for every 1 pumpkin, there are 4 bananas. Okay. Let's do one more. How about if I do bananas to apples? Remember, I can write it multiple ways. Well, my bananas, I have 12. My apples, I have 8. So the ratio is 12 to 8. You probably already realized that we can simplify it. So I can divide both of those by 4, which means it's going to go down to 3 to 2. All right, everybody, great job.